Hi guys, Radek here. I must say I'm very excited to start this online tutorial. This is the very first tutorial I'm doing online, so I'm really happy to be here, and I hope I'm going to help you do something very useful and very interesting and learn a lot of things along the way, because what I want to do is a set of controllers for Microsoft Flight Simulator, the latest version, the 2020 version. I'm in love with that game or simulator, however you want to classify that product. Since I was a teenager, I think I was about 12 or 13 when I first played the game, and since then I fell in love with flying. I don't have my professional pilot's license or recreational pilot's license yet, but I'm a paragliding pilot, and I managed to fly over the Alps and Himalayas, so the highest mountains on this planet. Yeah, I've been there, I flew. My highest altitude was about 5,000 meters above mean sea level. So yeah, it was wow, mind-blowing. But what I miss in Flight Simulator, in the setup or environment that I have at home, is a set of external controllers. And I know you might say that all I have to do is go online and order some of those controllers that are available right now. And true, if you go to Logitech website, you can find all this flight sim gear, which includes the throttles, the yoke, pedals, great screens like Horizon, radios, all that. It's all there, and the prices are quite reasonable, so you don't have to invest too much time or money and have good looking, great working, very well tested controls. And of course I was thinking about buying them, but then just a few months ago I started learning electronics. I knew nothing about electronics before, so Arduino, I knew it existed, but I never did anything with it. I know a lot about programming, not about electronics. I decided to learn electronics, I know programming, I love Flight Simulator, so I think I have all it takes all it takes to build this set of controllers. And if you feel positive about building something new, doing something on your own, then this is the place to start. My goal is not only to show you all the steps leading from or going from the concept to the final controller, but I want to explain what and why I'm doing, so you can learn a lot on the way, and I hope this will be a very useful tutorial. So let's start with saying what we're going to learn, and this is the plan of what we're going to learn. So custom MS Flight Simulator controllers. The first step is the introduction and environment setup. We are going to install all components that are necessary on our PCs, because Flight Simulator at this time is only available for Microsoft Windows, and also the tools I'm going to use are available for Windows only. So today we will define the goals of this tutorial. I will explain to you the architecture and explain why I chose to do things the way I did. Then we will install and configure all necessary tools, which is going to be very straightforward, very easy. Not much configuration is needed. In step 2, in the next tutorials, we are going to inspect SimVar's sample application. This is a great tool that is ready, available for free. It's part of the Microsoft Flight Simulator software development kit, and you can actually run this application, you can control the game with it, and you have the full access to its source code. So you can actually see line by line how the things are being done. And we are going to use this software extensively to get inspired and get some hints on how to do certain things, how to control Microsoft Flight Simulator, but not only. Then in step 3, we will build a basic Arduino controlled circuit, because of course what we're going to have on the other end is an Arduino board. It's going to control all the inputs and outputs of our controller. So it's going to control all the screens or the LEDs or knobs, displays, alphanumeric displays. So first of all, we need to build a very basic circuit, and it will only consist of the Arduino board, a single LED which will light up and turn off whenever something happens within the app. We'll define what it is. It doesn't matter at this time. Something happens in the app, the LED goes on or off, and there will be a single button which will also control something. I don't know, gear, flaps, whatever. We're gonna think about it. Maybe you will suggest something we should do, and we'll see if it works or not. And of course, the fourth step will be creating the final Windows driver or marshalling application. I will explain why I would call this marshalling application, and a final Arduino app. I don't know if I'm going to make the whole app online. Perhaps I will just share the code, and here in this tutorial I will just explain basic concepts. But that's at least a few weeks ahead of us, so let's not get too far into the future. And now let's see what we're going to do today. So the plan for today is, first of all, I want to explain why I want to use Arduino. You know why I want to do the whole project. I just want to do it on my own. I want to have a DIY project. But I will start by explaining why I will not use a very simple solution. There are libraries for Arduino which turn Arduino into an HID device, that is a human interface device. So it would work like a regular keyboard or joystick, and it wouldn't need almost any programming on our side. So why I don't take this shortcut, I will explain that in the first step. Then I will show you the architecture. It's not going to be very complicated, so don't worry. You will see all the components of our system. Then we will set up the environment. I will show you where to look for all the SDKs, Visual Studio installs, and Arduino IDE. So we'll do that today as well. Then we will test SimVar's application. And this is cool because you will actually see an app, an external app, which is not part of Microsoft Flight Simulator, which communicates with Microsoft Flight Simulator. So you will see some kind of interaction between this external app and the game itself. And then we will dive into documentation, and I cannot stress this enough, how important it is to actually know how to read docs. It's not very hard, but whenever I go to Stack Overflow, so this is, I think, the most popular forum for developers, I see some very basic questions which indicate that people who ask them did not go through any kind of documentation in their life. And of course, it's easier to ask someone else to solve the problem for us. But once you learn to study the docs, it's going to make your life so much easier. You will know where to look for information. You will know how to read and understand the docs that are delivered with all kinds of software, especially the Microsoft Visual Studio, but not only. And finally, we will take a very brief look at the SimVar's application code. I will just show you what it looks like. I will not analyze this because, as you remember, that's our step 2. But I just want to open the project and show you what's there, what's inside. Okay, so let's go to step number 1. Why not use Arduino as an HID, human interface device? Normally, what you use to control your flight simulator by default is your mouse, your keyboard, your joystick, and it's really very natural. You have all those things, maybe not the joystick, but the keyboard and the mouse. You buy the joystick like the one shown here. I'm using this one. so it has some throttle control. It's got many buttons. It's got a very nice yoke or stick that goes every direction. Plus, it can rotate on this Z axis, so it's very nice for controlling rudder. And we can make Arduino behave exactly the same. We can make Arduino another HID, human interface device. But the problem here is that those devices would only send information to Microsoft Flight Simulator. They can only send information. They cannot receive it. They cannot read anything back. So if you wanted to display like the radio frequency, or you wanted to display the status of your gear or flaps, it's not possible with joystick or your keyboard or Arduino acting as an HID. What we need is a two-way communication. We need to be able to send information to Flight Simulator and to read it back. So in order to achieve this, this is the system architecture we will be using. So we've got the game, the Flight Simulator, we've got the Arduino with its firmware, and we have to create this firmware on our own. We have to write the software which will be uploaded onto the board. And we need some marshalling application. This is why I said marshal. We need some interface. So our interface will talk both to Microsoft Flight Simulator and our Arduino board. And this communication goes both ways. So we have to be able to read and write from and to Microsoft Flight Simulator, and we need to both read and write things from and to Arduino board. So this is an additional piece of software that we have to make. We have to write it, and we're going to write it in C#. And the reason for that is that the SimVars application is already written in C#. So to avoid making things even more complicated and having to translate the C# application into Visual Basic or C++, I decided to write the driver or interface app in C#. But of course, you can write this application in any language. It could be Visual Basic, C++, C#, or anything else, because the most important thing, the underlying library that actually takes care of talking to Flight Simulator is a little bit aside the app we're going to write. And this library is called SimConnect DLL. And the SimConnect DLL is part of Microsoft Flight Simulator SDK. And we're going to download and install this today. We're going to get this SimConnect DLL, and we will make it part of our software. And this will take care of talking to Flight Simulator, and our USB driver, which is also being installed automatically with alongside Arduino Ide, will talk to Arduino. So we have interfaces talking to all components of our system, and let's not forget about the things we're gonna attach to Arduino. And this is where electronics comes in, because we have to know, and it's very straightforward and very easy to know how to connect LEDs, all kinds of knobs, displays, and other input-output controls to Arduino board. And we're gonna do all this within this tutorial, not this movie, not this particular film, because today we are just setting up the environment. So what are the required skills to go through this tutorial? It's not going to be hard. You don't need to know electronics too much. If you do, great. If you don't, no problem. But programming, you should know something. So we'll start by knowing, or at least loving, Flight Simulator. I love this game, and I hope you do too. If you don't, well, what a shame. But this will not be a problem if we're thinking about completing this course. Basic C#. the basic concept, the basic structure of the language. You should know that to fully appreciate what we're going to do with SimVar's application. Also, you should be familiar with Arduino Ide and the basics of C++, because the language used by Arduino Ide is C++. We're going to write software in C++, compile it, and send it to the board. Then basic electronics. And here, it's great if you know something. If you don't worry. You don't have to know anything, and you will still appreciate building that piece of device. Now, reading docs. If you know how to read docs, great. If you don't, I'm going to explain a little bit about how to read docs. The docs for MSFS SDK, so Microsoft Flight Simulator Software Development Kit. And the way this documentation is constructed is very similar to all the other documentation that is used by Microsoft. So all the docs for MS Visual Studio are very similar to what we're going to be using. And once you learn how to use those docs, I think you will be happy to find out how many things you can learn on your own. And finally, analyzing code. This is great to know how to understand the code that someone else has written, but if you don't, I'm here to help you. So these are the required skills. And now let's get through to the work environment. So all the components we have to have installed on our computer in order for our project to start rolling. So of course you need the game. So you need to buy it, install it. If you don't have it installed, do it now. It's going to take a while. If your computer, if your internet connection isn't very fast, then you might have to wait for an hour or two or many more hours to download all the assets to be able to install Microsoft Flight Simulator. The next thing we're going to install is the software development kit, and in order to install this, you probably need to have this game installed first, and I will show you why. Then we need some environment for writing the code, and I strongly suggest you use a free version of Microsoft Visual Studio called Microsoft Visual Studio Community. And the reason why I suggest you install this is that the solution or the project files that we're going to be working on are already created in this environment. So once you have MS Visual Studio Community installed, you will have no problems opening files that you will download along with SDK. And finally, you need this Arduino Ide, which is also a free environment, so you can install on your computer. And along with the Arduino Ide, some USB drivers for Arduino are installed, and whenever you plug in your Arduino to your computer, it's recognized as an external device, and you can easily communicate it via COM port. This is what we're going to install today. Of course, installing the game is very straightforward, and I encourage you to do this. And once the game is installed, I will now show you how to install the SDK. Okay, so we're inside the game, and now we can start working on getting our MSFS SDK. In order to do that, you got to go to the options in your menu, then choose General, and here you will see the Developers button. Select it and turn it on. And notice that once I turn it on, a small menu appears at the top of the screen. So I turn the menu on, and then in the Help menu, I've got this SDK documentation and SDK installers. And what you need to do is press this button, SDK installer. What happens when you press this button is you're going to be redirected to a browser, web browser, and your SDK will start downloading. So just wait for the file to download and install it. There's nothing complicated about installing this SDK, so I will give you some time to download it, to install this, and once you're ready, just resume playing this video. Hey, welcome back. I hope your game and SDK are all installed and in place. So let's see where to look for the library. If you go to your main hard drive, which is the C drive most commonly, you will see this MS SDK folder, and if you get inside that folder, you will see some subfolders and of course documentation. This is a very important one, so let's dive into it. Microsoft Flight Simulator SDK CHM. Let's see what it looks like. Okay, it's not the prettiest interface. I'm a bit disappointed that Microsoft hasn't developed a new way of presenting help, but okay, well, it's just for us developers, so we should get used to it, I believe. What we will be using and focusing on are the developer tools right here. So this is what we're interested in. Let's get right inside. This is what's in this section, and SimConnect is what I want to draw your attention to. So SimConnect is the library we're going to talk about. Remember that small DLL that was attached to our marshalling application I was talking about when I was explaining the system architecture? That's the SimConnect. That is this SimConnect library, and this is the whole documentation for that library. So let's look at what's inside. So the main chapter is the reference, and if you choose to display this page, you might be overwhelmed. So much information, so much code, variables. It's so user unfriendly, but believe me, you don't have to be afraid of it. It's not as hard as it seems, and I will show you what it is, how to use it, how to read it. Actually, the best way to understand documentation like this is to look at the source code, see how a particular method is being used in a working application, and then go back to the docs and see how this particular method is explained. And then you will just start connecting the dots and everything will start making sense. So this is exactly what we're going to do. We're going to look at a particular application, then see how various variables and methods are being explained in the docs, and we will try to use all that knowledge in to our advantage, and we will start looking for particular instructions to use in our target, in our final software. So I will just close that for a second. So this is the documentation, and also we've got samples, and I love samples directory because you will always find some nice things in those directories. What I'm interested in here is the SimVar Watcher. The SimVar Watcher, why is it called that way? Because simulator or simulation variables watcher. It's used to watch variables that are living inside the simulation world. What is a variable? Like, are the lights on or off? That's a true or false variable. Is the gear down? The radio frequency, the aircraft position or speed, these are all variables. Some of them are read-only, you can only read those variables. Some of them you can also write from the outside. So this is what we're going to use. And if you will get inside the SimVar Watcher directory, you will see this. This is the whole application, and SimVar's solution is the main file, is what you need to open to start working on that project. If you haven't installed Microsoft Visual Studio yet, Probably this file will not be recognized by your system. You will not see this nice icon because installing Microsoft Visual Studio is the next step we're going to take. And this is our Visual Studio Community Edition website. Unfortunately, I'm sorry, it's in Polish. I tried to change the address here from Polish to English, but of course they know better what I want to look at, and it goes back to PL. Well, whatever. Now you need to press this button, whatever it says in your native language. You need to download the file and start installing it. Once you download that software, you will use this Microsoft Visual Studio installer to select particular components you will be working with, components of Visual Studio that you need to work with. So make sure that after installing Microsoft Visual Studio Community, you will choose those two options. So first of all, support for C# development if it's not already turned on by default. But definitely thing that you need to check in the installer is the classic desktop application development, and it says Windows Presentation Foundation support. So you need to look for WPF in the explanation of all those options selected to make sure that you will be able to open the SimVars application. Those two things are obligatory. So once your game, SDK, Microsoft Visual Studio Community are installed, you should also install the Arduino Ide, which also contains, if I remember well, the USB driver for your Arduino board. So this is again where you need to go, and it's pretty much straightforward. This is the address. You need to type in your browser to go to this site and be able to download the software. So download it, install, and once you're ready, we will only have two more things to do today, one of which is really crazy and fun, and that thing is to actually try and use the SimVars application. Now let's get back to our SimVars Watcher application. Remember that on your hard drive you should have your MSFS SDK folder, then samples folder, and inside that folder there is the SimVar Watcher. And now you just open this SimVar solution file, and if something goes wrong and you don't know how to solve the problem, just post your comment, post your problem in the comments, and I will try to solve that problem for you, or at least direct you to a website or a tool to help you with solving that problem. But it should work out of the box. So you double-click SimVars SLN. SLN is for solution, and this is the main screen, and here we've got the start button. So all we need to do is push the start button. Now the program is compiling and the application window should appear. And here is how to understand what we see right now. So we've got the main connect button. If you have your game running, then it's gonna work. If you didn't, if you haven't launched your game, please do it now. So launch your game, choose your airport, choose your time, choose your aircraft and all that, and start flying. Do the start flying thing, and once the game is ready, then you might press this button, connect, and it's working. So you see this flashing LED. I think this is what it's supposed to simulate, an LED. So it flashes green and cyan. Now we have load file and save file. We don't care about this. FSX compatible configuration. Don't worry about that right now. Leave it unchecked. Also, this you don't have to care about, the user and object ID. What we need to worry about is this, and this is great. Look, there is a list of approximately 1,000 variables. 1,000 variables, or maybe even more. And those are all variables that you can write, you can read, and sometimes even write to MSFS. So look, we've got, let's see, gear position, gear right position, gear steer angle, and so on. Let's see, what else have we got? General engine fuel pump switch, general engine oil leaked percent. So there are many things: nav, GS, flag, localizer, outer marker, partial panel, airspeed, altimeter, altitude, avionics. Wow, there are lots of variables that you can get from MSFS. You can watch changes in those variables and react to them accordingly, however you want. So if we see that some variable is changing, then we can send this information to our Arduino, and Arduino will take care of whatever happens. So if we have the landing gear down, then it can light up an LED, or the characteristic 3 LEDs responsible for all 3 parts of our gear, which is wonderful. This is exactly what we want. We want to read information from MSFS and pass it on to Arduino. Also, we want to be able to react to user input on Arduino controls and pass this input back to MSFS. And this is exactly what we can achieve by using this application. So let's see flaps. Let's see flaps. Flap damage by speed, flap position set. It might be what we're looking for. Don't care about the index and units. We will not be using this. So we are now, we've chosen the variable name. So this is the variable name, flap position. And now we have to add a request. So we have to push this button in order to actually start watching that variable. And whenever something happens inside Flight Simulator, we will see that change in our application. So let's see if it actually works. I now have, as you can see, Cessna 172 with glass cockpit, very nice plane. And I'm in Bovic, it's Slovenia. It's one of the most beautiful places I've ever flown in, with my paraglider, not with a plane. This was the first time I actually flew 100 kilometers, and I flew in this area. So I know those mountains from above, being over all the mountaintops. And this was something absolutely fantastic. So if you ever visit Slovenia, you must go there. It's one of the most beautiful parts of that country. So let's go back to the game. Here's my beautiful Cessna 172. And as you can see, it's in its basic configuration with flaps retracted, gear down, of course, and this is a non-retractable gear, by the way. And in our SimVars application, we had been using or watching this flap set whatever, and we'll see whether we can read the position of the flaps in the game from our SimVars watcher. To control the game, I will be using my joystick. So I've got a key which is assigned to extending flaps. So let's see if it's working. Yep, I pressed the button. In my case, it's button number 9. And the flaps went down. Once again, they're even lower, and they can go one step lower right here. I can bring flaps up again, and up, and up. Yep. So let's see if it actually works in our application. I will be now pressing the button on my joystick, and I will see if flap position set will change. No, it's not changing. Perhaps I'm watching the wrong variable. So let's see what other flap variables we have. It's like flaps handle percent. Let's see if we watch this, add request. Oh, and it's 0.333, so maybe that's it. So let's lower the flaps. Now it's 0.666, so something is happening, if we get even lower, it goes to 1, which means 100%. Great, so it is working. Let's go up with our flaps. Let's go up. Yep, they're retracting, and the flaps handle percent went from 100% to 66%. Let's now try to use that nice feature. If you look here, we can try and set a value of some variable. Why does it say try and set value? Because not all the variables are writable. Some of them are read-only. So let's choose the variable, and since it says flat position set, let's use this. If I put 1 here and push the button, try set value, does anything happen? No, nothing happens. It actually says SimConnect data error. Well, okay. So let's try and choose another variable. So let's see the flaps handle percent and make it 1. Why not? Make it full flaps. Try and set the value. It's not working as well. Another error. So maybe flaps num handle position, add request. It's now 3 because we have 3 or 4 positions of flaps in this case. Okay, it says 3. Let's change it to 1 again. Try and set value. I first selected the variable. Now I put the value 1 and try set value. Not working. So again, I put the value 1, try set value of flaps num handle positions. Let's make it 1. Nothing happens. Another error, maybe value 2. No, nothing happens. So again, it probably is a wrong variable. You have to actually go around and test all kinds of variables. Also, documentation says which variables are writable and which are read-only. So we will get back to this later on. But here you can just try it out yourself. So num handle didn't work, handle percent didn't work, flaps available no. Handle index. Let's see the index. Add request. Select the variable, and the value stays 2. Let's see. Yeah, finally it's working. Have you seen that? It's number 2, and let's get it to 0. So we will be retracting flaps, pulling them up. Beautiful. Wonderful. So I can set flaps by setting this variable from outside the flight simulator environment, and it will actually work. So if I put 3, it's going to go all the way down. Great. So this actually both reads and writes variables. We can display status of our plane with our Arduino controllers, and we can set the status or configuration of our plane with Arduino, which is wonderful. I will now retract those flaps with my joystick just to show you that it's still working. So we can have multiple controllers controlling our plane. It could be our joystick, our keyboard, Arduino, or the SimVars Watcher application, which is absolutely beautiful. So okay guys, one very last thing for today, according to the plan I've shown you at the beginning of this lecture, is to take a very brief look at the code of the SimVars application. We will be analyzing this code in the next episode, and I will try to explain to you what all the parts of this code do. But the most important thing is to understand the structure of this application. So when you open the solution and look into the files that are inside that project, you will see that you've got the main window. So here is the definition of the window, and here you can see the design of the window. You can move things around and change their properties. You also have the code responsible for handling all kinds of events. So when you press a button or do anything else, something happens, and this is what happens. This is exactly the code responsible for handling this window. So this file is really the most important one, and let's take a brief look at this file. So I will open it here. So namespace simvars, and this is the class. No, not this class. This is the class we're looking for. Simvars view model. This is the class that takes care of communicating with Flight Simulator, and if you extend the definition file here, you will see all the important things. Receive SimConnect message, disconnect, of course, when we're disconnecting from FS. Also, I think it's do connect right here. This is what happens when we want to connect to MSFS, and this commented code is my code. I was testing this application before, so I should have deleted this, but what anyways, so this is a very important method. SimConnect on receive sim object data by type. Don't be afraid of this name, but this method will be called every time Flight Simulator sends a variable with its new or old value to our application through SimConnect DLL, because remember that the underlying library responsible for communicating with MSFS is the SimConnect DLL, which is part of SDK. And this method will be called every time new information comes from MSFS, and this is where we can see if this is the variable we are interested in. Like here, I was trying this app before, so I was listening for brake indicator, and if brake indicator changed to on, then I would light up a LED on my Arduino, and if the brake indicator was off, then I would turn the LED off. That's basically it. And this would give me this nice response from the app, and I could make Arduino behave in a certain way based on what's going on in the simulation world. So that's about it. You know what's the most important file. If you want to look at it on your own, please do it. But in our next episode, we will focus on understanding the code a little better. We will see what the documentation says about connecting, disconnecting, starting to listen for incoming events, sending information back to MSFS, and we will use that knowledge later on to actually get information from MSFS, send it to Arduino, or write information or send this information to MSFS coming from Arduino. It's going to work both ways. Thank you for today. It's been a very long tutorial, I know, and I'm sorry, but this is really the very, very first tutorial I'm making. So please leave a comment. Say if you liked it, if I should do something better, faster maybe, if you missed something and you want to understand something a little better. So leave your comments and leave me thumbs up, maybe subscribe to this channel. I'll be really grateful. Thank you very much, and see you in the next episode. Bye bye.